Assalamu alaikum. This is the continuation of the previous video. We started, learning about the kinematics of motion in a straight line. We learned about the difference between a displacement and the distance. We learned about that the displacement graph would be like this, and gradient of displacement will be equals to velocity. And we learned about the distance time graph, and we learned that the gradient of distance will be distance time graph will be equal to speed. Okay, as we know that if displacement is equal to s, this is displacement, and we learned that the gradient of displacement, that means rate of change of displacement, is equals to ds over dt is equal to velocity. And you know that what is the definition of the acceleration? The acceleration is equals to velocity is equal to ds over dt, and acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. That means change in velocity over change in time. And that means we got that the velocity is equal to ds over dt, and acceleration is equal to dv over dt. If we have a function and of displacement that is 10t square minus 5t minus 7. So if we want to find out what is the velocity, so velocity is equal to, you know that velocity is ds over dt, that is the derivative of the displacement, or you can say the gradient of displacement. So ds over dt is equals to, you know that the derivative is this power will be multiplied by the coefficient, and that will become 20, and 1 would be subtracted from the power, and then minus 1 is in the power, and that will be multiplied with the coefficient, and that will become minus 5, and 1 will be subtracted from the coefficient, and this constant, the derivative of the constant, is equal to 0. Why? Because this actually it has t raised to the power of 0 with that, and when you multiply this 0 with the coefficient, so 7 times 0 is 0, so this will become 0. So what is the derivative of the displacement? This is 20t minus 5. So if you are given the function of the displacement, you can find out the velocity by taking its derivative, and this is the velocity. Now, at some, as you know that this is a quadratic function. So all it's not a straight line. So in quadratic function, the gradient changes over every second minute, second step. Each every stage, the gradient is changing. Like gradient here is different, and that this is different. So at every stage, at every variable value of t, the gradient is changing. So this is the velocity at a particular time t. So if you're told to find out the velocity at find velocity at t is equal to 3, so that means velocity is 20 times 3 minus 5, and this would be 60 minus 5, and the velocity is 55 meters per second at time t is equal to 3. When the function of the displacement is given, this is the function of displacement, right? So if you're told to find out the acceleration, so what you are going to do, you know that what is velocity? Velocity is the derivative of the displacement, and acceleration is the derivative of velocity with respect to time. So that you can say that acceleration is basically equals to two derivatives of with respect to time of the displacement, because you can write it as d over dt of v, and this can be written as d over dt of ds over dt. So you can say that acceleration is equals to double derivative of second derivative of displacement with respect to time. So if the function for the displacement is given 10t square minus 5t, 10t square minus 5t, and this is minus 7. So ds over dt is equal to 20t square, 20t minus 5, and we'll be taking again the derivative d square s over dt square, and that will be this power 1 will be multiplied by the coefficient, and this will become 20 and power t 1 minus 1, and this is constant, and we have learned about before that why the coefficient, the constant derivative is equal to 0. So this will become d square ds over dt square will be 20. That means acceleration will be equals to 20 meter per second square. There is no variable left if it is a cubic function, like the displacement is given and 5t cube minus 7t square plus 2t minus 8. So you have to find out the velocity or the acceleration at some particular time. So that would be ds over dt. That would be this coefficient will be multiplied and one would be subtracted from from the power. So 15t square, and next two will be multiplied by 7 minus 14. One will be subtracted and 2, and taking second derivative d square s over dt square, that will be 30t minus 14. That means acceleration is equal to 30t minus 14, though now it's not fixed and it's changing with respect to time. At different times, the acceleration will be different. So what you have to do, you'll be asked at a particular time that what is the acceleration at this time. Like if they can ask you what is the acceleration, find acceleration, find acceleration at t is equal to 3. So a is equal to 30 times 3 minus 14. So 90 minus 14. So this is 76 meter per second square, right? Now, as you know that the derivation and integration are reciprocal functions of each other. Like if the velocity is the first derivative of the displacement, so you can say that displacement is equal to integration of velocity with respect to time. That means if you're given the velocity, so you can find out the function of velocity, you can find out the function of displacement through that by taking integration. And if you know that acceleration is change in velocity, per unit time. So you can say that velocity is equal to integrating acceleration with respect to time. That means if you integrate second time the same function, that you can have the displacement through the acceleration, right? Like you are given a function of velocity v is equal to t minus 6t square. They are saying you have to find out uh, the function of displacement. So you know that the velocity is change in displacement, d over ds over, this is ds over dt is equal to t minus 6t square. So if you bring this dt on the other side, this will be 6t square into dt. If you take the integration on both sides, so integration of ds, that will be s, the displacement, and this will become t square over 2 minus 6t cube over 3 plus k, where k is a constant. So I'll let you know how we have done it. This power is 1. So integration means that you have to add 1 in the power and you have to divide with the same 1 plus 1. And here this power is 2. So it would be 2 plus 1 and divided by 2 plus 1. So that means this power will become 3 and this will become 3. So you got the function for the displacement. As you know that, if the body started from rest, so that means at t is equal to 0, so sorry, t is equal to, if body started from rest, the t is equal to 0, the displacement is 0. So 0 is equal to 0 square over 2 minus 6 t, sorry, so this will become 2 0 cube plus k. So k is equal to 0. So that means what is the function of displacement? That is 1 over 2 t square minus 2 t cube. So you got the function of the displacement. Inshallah, we'll discuss some more topics in the next videos. Do subscribe my channel and click on the bell icon. Uh, uh, I'm sure that you have had a good time. Allah Hafiz.